Hi there. Today we're going to talk about writing and evaluating expressions. So I want to talk about a couple of words first that are in this title. So let's talk about the word expressions, okay? What this means is a mathematical statement without an equal sign, okay? And so an example of an expression would simply be like 2 times 3 plus 1, okay? And what I would want to do here is I want to evaluate this expression. So when I say the word evaluate, what I'm saying is to do the math. All right, it's as easy as I can make it. So when I have an expression here, I want to simply just do the math. All right, so the first thing I would do is I would do 2 times 3, which is going to give me 6, plus 1, which gives me 7. Now, what I want you to notice here is that there are no equal signs anywhere. All right, so when we have expressions, I don't use an equal sign. I go from one step to the next and work my way down, okay? So that's the idea between what an expression is. You see expressions all the time, and we want to evaluate them. So when you see that word evaluate expressions, that's what we've got, all right? Okay, the next thing I want to talk about are the 4 operations that we use in mathematics up to this point. And that's going to be the plus, addition, subtraction, multiplication, and division. And we've got a couple of words associated with this. So if I use the word addition, I also use the word sum, okay? If I am subtracting 2 numbers, I also use the word difference. If I am multiplying, I use the word product. And if we're dividing, I use the word quotient. All right? So all of these words, sum, difference, product, quotient, are associated with addition, subtraction, multiplication, and division. Okay? The next thing I want to talk about is the commutative property. Now, in the commutative property, that's when we reorder things, and we should get the same thing. All right, so for example, if we add numbers 3 plus 2 and 2 plus 3, we get the same value of 5, okay? But if I were to come in here and then multiply numbers, so let's say I do 3 times 2 and then 2 times 3, we get the same value of 6, okay? Notice how, regardless of the order in which I add numbers or multiply numbers, we get the same thing when we add and then when we multiply. The opposite is true for subtraction and division. All right, so if I were to subtract numbers, say 3 minus 2, and then look at 2 minus 3, I get 2 different answers. 3 minus 2 is positive 1, and 2 minus 3 is negative 1. I get different answers, okay? Same thing happens when I do division, okay? If I were to do 10 divided by 2, that gives me an answer of 5. But if I do 2 divided by 10, all right, I get something different, and that's going to give me 1/5 or 0.2, okay? So we get different answers if we switch the order in which we subtract or divide, okay? Now, the next thing I want to talk about is this concept of a variable, okay? And a variable, all it is a letter in place of a number. The next thing that I want to talk about is the concept of a variable. Now, a variable is a letter in place of a number. So we can really choose any number. Typically, we choose X, Y, Z, A, B, M, and N as our letters, okay? Most notably, we choose X, okay? But that's what we do, all right? So what I want to do is now write a mathematical statement based off of a phrase. So if I were to take the phrase, the sum of a number and 2, and turn that into a mathematical statement or an expression, I would simply just take the phrase, the sum of a number and 2, all right? So when I see that, I'm going to be using addition. And when I use of a number, I need to choose a variable. You can choose whatever you want. In this case, I'll choose x. But I'm going to say x and then plus 2 would satisfy this expression, okay, or this statement, all right? Now, I could also choose any number of variables and say y plus 2. I could say m plus 2. I could say r plus 2. I could say k plus 2. And I could say n plus 2. All of these statements say the same thing. The sum of a number and 2, okay? And that's what you guys are going to be asked to do, is to take something like this and either write a mathematical statement or an expression, or take an expression and write this out in words, okay? So let's look at a couple more examples. Now, if I were to come in here and say the difference of a number and 2 and write that as an expression, then I would write the following. I would say x minus 2. Okay, now I could also choose any other variable. All right, I would say like k minus 2 or m minus 2 or r minus 2. Doesn't matter the variable, okay, but I want to make sure that I'm saying the variable and 2. Now, if I were to come in and say the opposite, and say the difference of 2 and a number, then that would go the opposite way. All right, and I would say 2 minus x, or 2 minus k, or 2 minus m, or 2 minus r, okay? Now, if I were to use the statement, the product of a number and 2, then what I would do is I would come in here and I would say, I wouldn't say 2xx, okay? This here is wrong. All right, and because we're starting to work on some algebra, so this is wrong, so don't do that. All right, and we're using x as a variable. What we want to do is write this as, say, 2 times x, or you could say 2 parentheses x, or you could say 2x. All of these things mean the same thing, and that you're taking 2 and multiply it by some number x. Now, we don't have to restrict ourselves to just x. We could say 2k, we could say 2m, we could say 2r, we could say 2a, we could say 2b, all right? And the reality of it is that each of these things means the product of some number and 2. Okay, and typically when we multiply a number by a variable, usually the number goes first, okay? Now, the next one I want to talk about is using the phrase quotient. So the quotient of a number and 2 would simply just be x over 2. Or you could use another variable and say like, you know, m over 2. All right, and what we want to do is kind of get away from using, say, x divided by 2. All right, let's move away from this. While this is correct, let's not write it like this, all right? Let's write it in fraction form, okay? And so what you'd want to do is some number in 2, all right? And so the order in which that this is written is how we want to write that expression out. Now, if I wrote it as the quotient of 2 and a number, what I would then want to write would be 2 over x, 2 divided by x, or I could write this as 2 over m, or 2 over k. All right, it doesn't matter the variable that I use, as long as I do use a variable. All right, so of a number means we don't know what that number is, so we put in a variable to show that. The next thing I want to talk about is this concept of substitution. And substitution means that we replace a variable with a number. So let's look at an example real quick. And so when I do this, I want to evaluate the following expressions when x equals 3. So what I'm going to do is I'm going to take the fact that x equals 3 and I'm going to substitute it into x of each of these expressions. All right, and these are the expressions that we wrote down, x plus 2, x minus 2, 2 times x, and then x divided by 2. All right, so my first one, what I'm going to do is I'm going to write this out, and I'm going to say 3 plus 2. Okay, and so when it says evaluate the expressions, it means substitute 3 in for x and then do the math. All right, and all I know is that 3 plus 2 is going to give me a value of 5. All right, and that's my answer. Over here, I would plug in 3 for x and then subtract 2, and then I do the math. 3 minus 2 is going to give me 1. The next one, I would do 3 and then 2 and then x. And what I'm going to do is I'm going to put this in parentheses to show that I'm multiplying those numbers. Okay, remember, if you've got a number next to a variable, that means multiply. When I plug that number in, I put it in parentheses. So 2 times 3 is going to give me a value of 6. All right, and then if I plug it into my last one and I do 3 divided by 2, then I'm simply just going to do 3 divided by 2. And I could leave it like that as a fraction because 2 doesn't divide evenly into 3. But if you put that into decimal form, then that would end up giving you 1.5, okay? So that's the idea, all right? And that's what I want you guys to be able to do, is to use the concept of writing out these expressions, substituting variables in, and then evaluating and doing the math. So I know this was kind of a long video, but there's a lot of information. So please let me know if you have any questions, and we'll talk to you soon. Thanks a lot. Bye.